This is a screencast for DevOps CSC 791 final project submission. We have built a continuous integration pipeline with 3 steps: the build step, the test and analysis step, and the deploy step. For the first 2 milestones, which are build and test milestones, we have used a Java Maven project. It is an Apache Commons project, as you can see on the screen. We have used GitHub, Jenkins, Findbugs, and Corpachura for these milestones. The process that we are following starts with GitHub. Whenever a developer commits something to GitHub, a Jenkins job gets triggered. The Jenkins does an MVN build, and then as a part of the post-build step, it passes the build project to Findbugs and Corpachura. Findbugs is used to perform static analysis, and Corpachura is used to determine the code coverage. These two tools also act as gateways to decide whether the build is success or a failure. As you can see on the screen, this is a Findbugs gate, and you can see in the report that the build has failed because Findbugs threshold was breached. Similarly, we can also set thresholds on the Corpachura plugin. The methods are 80%, lines is 100%, and conditionals is 70%. These indicate what are the thresholds for these respective types of code coverage, and if they are breached, then the build is marked as a failure. We have also used Rundo to randomly generate the test cases. So as you can see on the screen, this is a code coverage report before the randomized tests were used, and this is the new code coverage report after the randomized test generations were used. And you can clearly see an increase in the code coverage in this report. We have also developed a custom Findbugs rule, which is used to detect whether the classes in your source code start with a capital case letter or no. And if not, then they raise a bug of type 1. For the next milestone, which is the deployment milestone, we have used GitHub, Jenkins, Amazon EC2, Amazon AWS Code Deploy, and Ansible. The project which we have used is called SnapPass. It is something like Snapchat, but it is used to share passwords online. We have created 2 branches in our GitHub repository. One is a developer branch and another is a production branch. As soon as a change is pushed to the production branch, the Jenkins job respective to that particular branch, which we have mentioned as share pass, gets triggered. It pulls all the changes, it does an npm build, and this build project is sent over to the Amazon S3 bucket and then gets pushed onto the respective EC2 production release instances. For configuring these EC2 instances, we have used Ansible, and we are setting up everything that we need to build this project, build and deploy this project. For example, everything from Redis, npm, Node.js is configured using Ansible. So now, whenever a developer wishes to perform a canary release, he commits to the developer branch. The developer branch change gets picked up by the canary release Jenkins job, and it gets deployed to only those instances in our production system which are marked as canary. So as you can see in the AWS code deploy page, we have 2 different deployment jobs. The first one is called as the canary deploy, and the other one is the AWS code deploy. The canary deploy only basically deploys the application to one of the canary instances, whereas whenever a change is triggered to the AWS code deploy, it deploys the change onto all the production instances. So as you can see, there are 2 versions of the same application that are running. The first one is this canary release, which is marked as 1.6 with the color changed, and the other is the production release. Our special milestone is made up of 3 parts. The first one is Ganglia. Ganglia is a distributed performance monitoring tool, and the other 2 parts are parts of the Simian army, which is a chaos monkey and a burning monkey. The setup of Ganglia can be seen on the screen. A daemon process called gmon is present on each server in your production system. This gmon daemon collects the CPU, IO statistic, and other node-specific data on each server, and this gmon process sends something called as heartbeats to the monitoring node. The monitoring node collects these heartbeat data from all the servers and aggregates it, passes it, and displays it in a UI. The UI for Ganglia looks something like this. You can monitor the current load, the memory, the CPU power that is utilized, and the network. So basically, this is monitoring the entire cluster. And over here, the cluster refers to the collection of all the production systems that you have. Moving on to the next part, we have developed a chaos monkey. This is a Python script which takes in as an argument the region of the machine which you wish to destroy and the access key and the secret key to all your production instances. It connects to them and at random it selects one of the machine and it simply terminates it. You can see the chaos monkey in action in the screenshots shown ahead. So as you can see, we have simply run a Python script and it runs and it shows that these are the current production instances which you have, and it specifies that it will randomly delete one of the instances mentioned below. So in the next screenshot here, you can see that there are two machines which are marked as the chaos monkey test and both are running, and after the chaos monkey was run, you can see that one of them is shutting down. So the next monkey which we have implemented is a burning monkey. It is a very simple shell script which simply connects to a machine and starts a CPU burning script. And as you can see in the screenshot, the CPU burning script, which is called as the burn CPU script, is at the topmost process in the top command of the Ubuntu system, indicating that it is utilizing a lot of CPU power on the server. So this is the aggregation of all the milestones that we have done throughout the project. And thank you.